Hi, everyone. So I want to welcome you to this week's edition of the FRC Workshop Series. We're really pleased tonight that we have Evan from Normanhurst Boys High School, Team 4739, and he's going to be presenting on, I hope I say this right, CADllabration. I'm pretty excited to hear what they have to say. I've heard that this has revolutionized their team. So Evan, I'm going to turn it over to you, and I hope everyone enjoys the presentation.
Yep, thank you for that. So just need to share my screen. So this talk is about version control, collaborating with CAD. And this is going to be kind of a bit different because I'm not going to tell you exactly what to do. I'm going to go through a few alternatives and methods, and I think that it's best for teams to decide for themselves what their best approach for them is. So first, we should ask why we want to collaborate. Why not just have one person do it? It allows anybody interested to participate in the program, which is really what FIRST is about. It increases transparency so people know what's going on in the team instead of just drilling a hole and not knowing what it's about. It increases your bus factor, which basically means that if something goes wrong, if somebody gets sick, if somebody can't get into the country, like what happened to some people this year because of coronavirus, they were stuck in another country, your team can keep going because there's more people doing the same job. It can lighten the load, which is especially important when people get into senior years and they need to start studying for the HSC, because work is shared. And you can also, with that additional time and resources, look into more advanced and detailed designs, which can help you in competitiveness. And also it allows you to review your designs before they even go into the production, because more eyes pick up more mistakes, which can prevent issues before you even start building the robot. So I'm going to go through a few different tools which you can use. So there's just ad hoc sharing, which most teams would start off doing. There's network shares, stuff like Google Drive, maybe SMB shares. You can use online CAD tools such as Fusion 360 or Onshape. And then finally, Git, which is the main portion of our talk today. So starting off with the tools apart from Git, you've got ad hoc sharing. That can be sharing one desktop or one laptop. You just pass it around people in a meeting. Working off a single drive like a USB stick, you just have your CAD files there. You give it to somebody, they take it home, do some work. They bring it back at the next meeting to give it to another person. And manually combining changes together. If two people make changes on a file, you just email it to each other. And that's generally the easiest type of sharing, but there are some drawbacks to that. Like, as I mentioned before, you can't really have as many people working on it, and merging things together between different machines, that can be difficult. And also your CAD can get lost on that hard drive, which is not going to be fun because that's hours of work lost. And then the second most advanced solution is network shares, which I reckon quite a lot of you would be using, which is something like Google Drive. Some teams which have a large computer area might use SMB shares, which is basically when you have a hard drive connected to your computer, like the F drive. It looks like it's just another hard drive like your C drive, but that's actually connected to a server somewhere. Autodesk Vault is another solution, but that's a paid solution, and there's issues with that as well. But these solutions require you to be always online, which can be an issue if your school blocks some of these services or there's unreliable internet in your area, which happens a lot in Australia, so it's not ideal. Files are locked to prevent conflicts, and that's basically just a fancy way of saying that only one person can edit a file at a time. So if somebody tries to open a file which you're editing and is locked, it will just give you an error, and that's how it makes sure that there's no conflicts. And now there's CAD solutions which are designed to be online and are really integrated with sharing CAD online. And these are Fusion 360 and Onshape are the main ones. I'm sure there are other solutions, but those are the two big ones. They are very easy to set up compared to some of the other solutions, like setting up Vault and SMB shares can be a really difficult task, especially for people who aren't that technical. They're always online, but it's not as bad as the network shares because you can go offline with these tools, but you lose a lot of functionality. Like Onshape just stops working at all, and Fusion 360, you can no longer save properly. And also these online solutions, despite getting better, they don't have as many tools and features as the full programs. Like Fusion 360 does not have all of the features which Autodesk Inventor has, and Onshape is not as fully featured as Inventor, SolidWorks, and other similar solutions. So finally, we get to Git, which is an attempt to address some of these issues. And this is something our team has been using for the past year, and we've had mixed results with it, but I think that'll be useful to look at. So why would you use Git? It's an industry standard, not necessarily in the engineering industry, but in the software industry, it is a big thing. Almost all companies use Git in some way, shape, or form. If you look at GitHub, many major projects are there. It has very powerful features for collaboration inbuilt, such as branches. So you can have two parallel versions of some sort of design, and then you can combine them together. It can have merge approvals. So people can't just add to the CAD. It needs to be approved, these changes. You can have major releases, such as you can say, this is version 2 of our robot. I want to give it to the manufacturing team now. It also has support for plugins and hooks, which I'll get to much later, because that's an advanced feature. And it works offline, which is a huge deal for some teams, especially ours. But it, of course, requires a internet connection to be able to synchronize changes between machines. So what is this Git system? It is a version control system, or VCS. There are a few other alternatives like SVN, but Git's the main one. It was created to manage the source code of the Linux kernel. And if you don't know what that is one of the largest collaborative software projects in the world, and thousands of people have collaborated with it. But it can also go down to very small projects, such as 2 people doing a software project or 2 people designing a robot. It is the most widely used, as I said earlier. And like I said earlier, again, it's generally used for code. So Git is just a protocol. Yeah, it's just a version control system. You need to have somewhere to put your Git stuff. So a host is someone who hosts this Git server online. Our team uses Gitlab. There's a few reasons for that, which we won't get into. But most tools don't really care which one you use. So I would research all of the providers. Alternatives include GitHub, which is the largest. You can run it on your own computer, which is called self-hosting. And there's also Bitbucket, which is run by Atlassian. So you can have clients where instead of using the default way to interact with Git, which is using a command line, you can use a client instead. They offer a nice graphical user interface. There is not really any new functionality introduced by clients. It's just a nice skin on top of the command line. And it doesn't matter what client you use, they're all very similar. But it is kind of a crutch, so I wouldn't recommend it that much, especially for CAD, because it can introduce issues. So what is a repository, which is how you store your CAD? Like, how is that set up? So you see you have branches. So the default branch is called master. On GitHub, this will be called main. So then you can split off master, these branches, such as for this component, or, component B, this might be your intake. And then you can say, I'm not sure about how I want to design this. I want to make a different version of this. Like say, what if the intake is horizontal instead of vertical? So you can continue these branches. And as you can see, they're all over the place. They're all, parallel together, so which is good. And then you see these branches converge into one, and that is where you combine them together. So file structure. This is just a file structure which our team uses. So you can use your own, but this is one I recommend. Every assembly is in its own folder. Every assembly folder contains the parts and sub-assemblies which it requires. Sub-assemblies are obviously in separate folders as well. This one is questionable, which is just how we do it. Part should be copy-pasted instead of directly reused. You might ask why that is. It's because if somebody edits the part for their particular sub-assembly, it will edit it for you as well, which can cause issues for you if you depend on the original version. And every part or assembly for us is associated with a drawing file so that it's actually useful for manufacturing, because I can't look at 3D CAD files. Yeah, and we just have them in the same name. So there's also a file in Git called .gitignore, and that basically just tells it what files which the Git shouldn't care about. This is, a minor point, doesn't really matter, but it's useful for ignoring files which Git shouldn't really care about. So now we get onto how to use Git, and I'm just going to do a little demonstration. So the first command which you'll need to use is commit. But first, we need to just make a folder which we're going to be working on. So I'm just going to do an example one, example. So as you can see here, the folder is empty. And then, okay, let's run the commit command, git commit. It will say that there's no repository. And that's because before you start using Git, you need to create a Git repository. So that's just a Git init, which just created a Git repository in the current folder. And now if you now you just need to add some files. So you choose what files and changes you want to make. So I'm just going to edit a file, test. This is a test hello. Just going to save that to a text file, which is just a basic text file with that text in it. So now we can so now before we commit, we have to go add files, which we want to commit to it by running the add command. And that just says that we want to add this, the file test to our repository, and then we commit it. So we just need to enter a message such as added the test file. And this is just a friendly message which you have to use to basically tell others what the change is. So you just save that. And then we have successfully made a commit. This is just stored on our machine for the moment. And, it gave it a name and description. And since I didn't actually push anything to the server, I can do this completely offline. So if I pulled out my Ethernet cord, obviously wouldn't do that because I'm on a meeting right now, I could still do this, which is quite useful. And also, just as a bit of advice, these commits should just be a single change. Don't make a whole bunch of changes and then do a commit, because that can cause issues. So pull is how you get changes. Obviously, there aren't actually any changes yet, so I can't really do that. And it retrieves all the commits from other people's server. But first, before we do pushing, pulling from the server, we need somewhere to do that from. So this is just the dashboard for GitLab we have up here. So we can just create a new project. I'm just going to create this for our team. Don't need a description. Just create project. And as you can see, it's giving you a bunch of command line commands. This can be a bit scary, but you can more or less copy paste this. Yes, I know this is kind of frowned upon, but it's fine. So just remote add. And that command, remote add, that's just saying I want to use this server to put my changes on. And then here's the push command, which is sending the changes we made to the server. And now other people can see the commit. So if I refresh the page, we can now see the file which I made earlier, the change I made earlier. This is a test hello. Yep, that's exactly what we wanted. And also, you should make sure you push the server often to make sure that other people get your changes so people can look at it, and also so that you don't lose any work. Now, bit back to pull. I can edit this file online in this editor. So I can just say ABC123, just a random change. But if I look at the contents of the file, it's still the same. This is a test hello. So that's where you use the pull command so that you can synchronize the changes, because Git doesn't do anything automatically for you. This is not like Google Drive or Onshape where it automatically gets the changes for you. You need to explicitly run a command, which is git pull. So yep, that just got the changes in the file. So now if I look at the contents of that file, it is the same as what we have here. This is a test hello ABC123. So that's pretty basic, but that's no real advantage over something like Google Drive. So now we get into the most powerful feature of Git, which is what are called branches. So you create a branch by running the branch command. As you may start to notice, these git commands are just the keyword git followed by the command. So I might have git branch, and then I'll have then I need to create a name for a branch. So I'll just call it, ABC. Obviously, you should give it a proper name to it. And as you see, all the files are the same, completely unaffected. And just as a word of advice, you should have a branch for every meaningful design idea. Branches don't cost anything, so I would recommend doing it all the time. And now this new point, all branches are independent. That basically means that if we were to do a change on the current branch which we are on, which is the master branch, the default, if I was to edit the test file and say, here is some more data, and then I add, and then I commit the change, and then what I can do is I switch branch with the checkout command. Git checkout ABC. And then now if I look at the contents of that test file, it is back to the original one instead of the modified values. And now if I change this file, I can add additional lines to it. So, whoops, title, because, I forgot to add a title to this file. Usually if there was something like Google Drive, that would be catastrophic, because now you have two different versions of the same file, and it would have no idea what to do with it. You'd have to throw out one set of changes, which means that you lose work and you have to redo all those changes. So this is the second powerful feature related to the first in Git, which is the merge command, where you basically combine changes together. So first I need to make sure that the files are on GitLab, because it's easier to show this on the graphical interface there. So yep, it just set up there, and it combines two branches together. And you use it when you want to add parts of one branch to another. You combine them together. And then the merge request feature is an online feature on the version control dashboard. I'll get into that a bit later. So, okay, so how do you combine two branches together? On GitLab, at least, you just create a merge request. Create merge request. You can say, I want to combine ABC with master. You'd usually write a description for obvious reasons so people know what this is. There's all these other attributes you can have. Submit merge request. And so yeah, you look at this and make sure that things are how you like them. Oh, whoops, forgot to commit my changes. So I've got to refresh the page quickly. And then Git makes it quite easy. You can just click this merge button and it combines it together, because it found no conflicts. And you might wonder, wait, but aren't these two different files completely different? They changed? Well, that's not the case with Git. Because if you look at this text file, it has now successfully combined these changes together. It has merged them together, which is exactly what you want. Now, just some things which you do to administer the repository. There's on both GitHub and GitLab and most of the other ones, you can create what are called issues. Oh, sorry, wrong thing. Also some, so that's just some basic use of Git, but there are some drawbacks and issues with that. The GUI clients, they do exist, but for CAD, they can fail in weird ways. And I'm going to get to that in a bit. The command line can be very intimidating for some people. Like, I'm sure quite a lot of you would have been confused by whatever this was. Repositories can take up a huge amount of space. Like, I've got an example here. This is a very basic design repository, which was for this year's robot. Geez, it's been a long time. And this was when we were still doing a trial, so there wasn't, complete use of it. It's 2.2 gigabytes, but that can rapidly increase to something like 20, 30 gigabytes, and that will take a long time to download. It's cumbersome to deal with, and some services may refuse to even deal with files that large. And also with CAD, you can't merge files. And it can cause data corruption if you're not careful, but if you're careful, you shouldn't, but that's still a risk. And then you also have to make sure that your generic files, like bolts, are all in the same place. You make sure that you commit them as well. It's because stuff like Autodesk Inventor does weird things. So now what do I mean about CAD is different? So I'm just going to launch a CAD program here, just free CAD. So I'm just going to, model a part very quickly. Just, cylinder, yes. So close, and then I'm going to extrude that. There's part design. Oops. Oh. Oh, sorry, let me start that again. Okay, body, create sketch. And this should be a very similar process for other CAD tools you just had. So yep, I just create a cylinder, doesn't really matter. So I'm just going to save this to the same place as before, just in my Evan folder. Where's example? Example 1. CAD. So yep, just saved it there. And we're still on the ABC branch. So you can see we have this cad.fcscd. That's just a free CAD file. Now, if we try to look at this in a text editor, we just get absolute garbage in here. You may be able to recognize some text and patterns, but this is binary. And Git really does not like that. It's fine if we just, add it to our repository. Commit, yep. Added a CAD file. You can do, git push. All your normal operations. You think, oh, that's fine. But what if we do git branch, EDF, and then on this branch, we continue to edit it. I'll be like, you know what? We need another hole in this. So, you know what? Yeah, I want a nice hole here. Yeah. Second hole. So, yep, there you go, which is completely different now. Yep, save that change. Close that. And now if we move to that other branch, so we move to EDF, and we reopen that. Oh, sorry, you just need to go open it from the open menu. Excuse me. Come on. Just continue to make some changes on this branch. So, create another sketch here. Oh, more circles, rectangle this time. Close, pad, we add a rectangle. modified file. And then we just push that to Git. Repository. And then we can just create another merge request, and you would think that it would combine those changes properly. But, you know, new merge request. So we're going to go EDF to ABC. Wait, was it? It's into EDF. Yep, don't need a description because we're being lazy. And then we go back to that merge request. This one I open. Oh, sorry. Oh, we just need to go make sure that we actually make changes. Go back to our CAD program. See, it's back to this state. So yeah, that's reasonable. This is where we left it off on this branch. So then, oh, you might say, oh, you know what? I want to make this. Cylinder a bit smaller. So bring that in a bit. Yep, bit smaller. Done. So again, you add and then you commit. Okay, there's some changes. And then you'll see this thing saying there are merge conflicts. And it says you must manually merge it on the command line. That's not something we want to see. Was last time it could combine them fine, but this time it's giving us an error. And that's because it is a binary file. It's just ones and zeros. It doesn't understand it. Git is designed for code, and code is written in text. So you have an issue, and then what you basically have to do is you have to decide which one you care about. You either keep the changes from one branch or you keep the changes from the other. You can't combine them together. So that's the main issue. So we'll get to some ways you can fix those issues later. So onto some more positive aspects of Git. You can have permissions so that you can allow people to do certain things. Like when I was messing around the repository and pushing things onto master and forcing things, that's usually not what you're not allowed to do. It's just because I'm the administrator for this team, I can do stuff like that. Some branches are protected, which means that you can't directly put stuff onto it. But because of these permissions, you don't just have to give Git to trusted people in your team. Anybody on the team can use Git because they can be placed into an area where it won't affect the robot. Suddenly your parts won't be incorrect. They can be reviewed beforehand. And like I said, dangerous operations can be restricted to a very small group of people. And you might wonder, what are dangerous operations? So I can go check out master. So then I could say, I could remove everything. So LI. So I could remove the Git, and then I could remove the test file, Git init, and then I can connect to this. Then I can connect to the server again. Git remote add. Team -4739 example 1.git git push. Now this is empty. It's saying, oh, first I need to go do this. So yeah, it's complaining, but I can just do this. I can do I can just force things to happen. Excuse me. Well, I'm not sure what happened there, but usually the force command, that would delete everything in the repository. Was it just saying, I don't care, overwrite everything? So yeah, you obviously don't want everybody in your team doing that. So, and to help with this, we have merge approvals. And you could see with merge requests, we could have approvals and we could add rules to it. So if I edit this, I could say that for me to merge this, I need, I could add a rule. I could say that I want rule. I could say that I want, you know, our lead technical mentor to approve this before it is approved, before we can actually merge it. Save changes. And then if I want to merge, then it won't let me, not only because there's conflicts, but also because this person hasn't approved it. And that way the CAD can be checked to make sure it is good quality and it can find, and it doesn't conflict with anything before you combine it together. So people can't just rush changes through. And that can be accessed through this dashboard. GitHub has a very similar thing. And like I said, maintains the quality of design. And also you can add comments for why it's disapproved. You can say, this has many issues. Just comment that. Then say the person who has made this can see that and they can address anything before it is combined. And discussion can occur here or can occur offline in other services such as Slack as well. So, and transparency, all members are able to view anything. There's no reason to have things private. You might not want to have other teams see it, which is what we have. If I was to go into settings, you would see that this is private. I forgot where they put it, but yeah, there's a little padlock there, private, which means that only people in our team can see it. And leading on from that, you should make sure that your documentation and your drawings are really accessible to other team members, just so that they can read it as well and they can understand what's going on in the team. And also, because of this commenting feature, people who aren't on the design team can still ask questions or contribute to the CAD. And also non-design members can be part of the approval process. Like for example, this season, we made it so that members of the software team had to give approval, for example, so that they could say, oh, I don't like where this sensor is placed. We won't be able to program properly unless you move the sensor. And that way that all people involved can give approval, so that you don't just dump things onto your programmers or elect team and say, fix it, because that's really not good and it can cause conflict within your team, which you want to avoid. And issues. Those things I mentioned before can be done through issues. You can create a new issue and say, where are the sensors? I see. Yep, you can add a description if you want. Submit issue. Anybody can submit issues. You can thumbs up, thumbs down things about issue. They are, and you can also add comments like before, here. And also you can upload things to it for these issues. And you can also assign these issues to people and combine these issues together. For example, you can say, I want this to be assigned to Arvin, who's also on our team. And they'll say, I want him to be dealing with this issue because he should be the one resolving it. And you can do that so that people can say, oh, this is your job on the CAD. This is a convenient way inside GitHub and GitLab to basically assign duties to people without having to try to coordinate in a different manner, such as through Slack. And it can be used for clarifications on or issues with CAD. And like I said, you can be assigned to people. And also tasks that ties into issues, it's about the same. And also you can you can assign some of these issues to new designers so that you can give them a test run. Like you can give them an issue which isn't time critical. And you can say, oh, it doesn't matter if after 2 weeks they couldn't finish it. One of our senior designers can fix it in 2 days. They can do it if they've done a good job of it. But if they have been able to do it, then that shows that they've got initiative, they've got the skills, and also that's less work for the other people on the team. And some general tips. All of these names I've been giving, those are really, really bad. I've just been doing ABC, EDF. That's really bad. You should give them appropriate names. If a file isn't used anymore, you can delete it, because it's not like your computer where if you delete something, it's gone forever. It's still on the version history. Like I can go through the merge requests and closed. Oh, sorry, merged. Look at this one. I can still see the changes which are made all the way back up here, so I can get things back if there's issues. I can even download this file if I want. Design accelerator, don't worry about that. And then also make sure the parts libraries are a consistent location, because something which, for example, Inventor and I think SolidWorks does is it says I need a bolt at C/whatever/M6 bolt, and that can cause issues if the bolt isn't there as well, because when somebody else gets the CAD, it'll get confused, like, where's this bolt? I'm not going to show them, and that can lead to all sorts of issues. And also, just as a bit of courtesy, if there's errors in your CAD, try not to commit it, try to fix it first, because that can cause a cascade of issues with other people's CAD. And also make sure that each assembly is in little bit of parts, in small parts, because as I said before, you can't really have the same file edited in multiple places. So one way to avoid that issue is to just combine it, to split them into smaller pieces. So that's very unlikely that multiple people would have edited the same file at the same time. And also, if they did edit it, it's not too difficult to combine the changes together manually. And that basically just means make sub-assemblies. And now some advanced options. These are not things which we have done our team yet. When all of these previous things, these have been things which you have directly done. But these are things which your team can look into, and these are things which our team is currently looking into. And the first one is alternative CAD packages. Because as I said before, it really doesn't like it when you have weird CAD files, because it just says, no, there's a conflict, I'm not going to deal with this. And some of those are FreeCAD and BricsCAD. You might be wondering, hey, didn't FreeCAD break before? I've been kind of disingenuous there. You can get around that with FreeCAD at least, but yeah, that's for you. You avoid proprietary file formats. Basically, a project we've been working on is a way to convert FreeCAD, because it's open source, and just be able to convert that into just a text file which Git can deal with. So come on. So where's that? Test dump. So you think, oh, this is the CAD file from before, and you can see it's text. So there's a method you can convert into text, but that's still something we're working on. It's easy to write extensions for these programs, because it's open source, it's well documented, which means you can add additional functionality for the teams who want or need that sort of thing. And it has reduced the repo size. Because it's text, it can compress it better, because every time if you have a binary file, like the CAD file I pushed before, every time you make a change, it has to store the entire file. It can't just store the differences. And that really adds up the size over time, because it just has to keep, adding stuff, and you can't really do compression. But the issue with these is these are not as fully featured as the industry leaders, as the aforementioned, and not as fully featured as Inventor or SolidWorks and similar solutions. And they can also run headless in a server, and I'll show you why that's interesting or important later. And you can have hooks, which are little functions which run when I run git commands like git commit. I can make that run a function before and after the commit. Why is that useful? It can integrate with the CAD. That is how we actually do that's how we implement it, converting those CAD files into text. And then also when you pull it down, it can convert it back from text. And you can also do that for checking to make sure that your CAD files are in a good format and there's no issues as well. You can write extensions for your CAD programs as well, such as instead of having to use this command line just as a separate program to your CAD program, you might find a way to integrate it directly together with it. You can have systems which cross-reference a stock database, such as interface with a supplier catalog, such as AndyMark or Vex or other suppliers you might have, such as Bunnings or whatever. That way that you can drag and drop for an interface. I know that some professional CAD programs also have that. Don't remember some off the top of my head, but I know for stock databases, there are SolidWorks and Inventor have the part library. Oh, I accidentally went back. And also, to do quite a lot of these things, you may have to run your own server, which is self-hosting, as I mentioned quite a bit earlier in the presentation. And that can be running your own Git server. And that allows you to interface with other types of servers. Like our team has a SQL server. Come on. It's loading. Can't connect to that server. Yeah, but never mind. That stores information about our current stock levels and also about members on the team and the jobs they're assigned. So you can integrate those together. You can run that on a cloud provider such as AWS, Google Cloud. Those are the main players. Or you can run it on your own hardware, as I'm doing. I've got the desktop, which I'm using right now. That is currently what I'm using to run these servers. And also keep in mind that this can be quite expensive. Like AWS, they can charge you hundreds of dollars a month if you're doing anything too complex. And a server can cost hundreds, if not thousands of dollars. So unless you have it lying around and using for other things, it's quite an investment and quite a large thing. As I said before, it allows large repositories and pipelines. And pipelines, what are pipelines? Well, they are programs which run when you push files to Git. This isn't a CAD example, but I can show you an example of a pipeline that we have. Pipeline CI/CD. So this pipeline. So you can say it's from this commit. And then what it did was it built a package. It deployed the package to our server. And it created a testing ISO. And all of that was done automatically. I didn't have to manually run any functions. It's just that when I pushed code to GitLab, it automatically ran commands for me. And that is really useful if, for example, you want to convert all of the CAD files into drawings, which your design team can use. And then you might put those onto a server. You might put them to Google Drive so that people can access it. And then after that, you can send an email to people saying, hey guys, the design has changed. Please take a look at it because some of the stuff you're building might be out of date or might have changed. And it is run in a system called a container. What if we look at this? All of this is running in the command line like this. But this isn't running on their servers, it's running in a container. Won't get into exactly what that is, but that's basically just a way for them to provide a fast machine to you for these to run on. And yeah, as I said, generate reports. You can run tests on your CAD or your code. So that way you can say, oh, make sure that no parts intersect, which obviously you can't have in real life. And it might say, no, I'm not going to allow this because parts intersect. You can create and deploy instructions. And also you have integrations as well, where you can, which you can see here, are settings, integrations. And you have all of these programs which you can integrate CAD with. The ones which we use is, where is it? Yeah, we use the Discord notifications. So let me get that up quickly. I'm just going to and that basically just tells us when there's a change on GitHub, so that because we spend a lot of time on Discord, there's similar things for Slack, and also you can just have emails. And that way you're notified if there are any changes. So basically just prompts people to have a look at it. Okay, there it is. As you can see here, there's an automated message basically saying, oh, there was some changes. So yep, Discord and Slack bots, automated emails, as said before. You could also integrate with your own custom desktop app. That's quite an advanced thing. Wouldn't recommend it. And also all of these things are, there's an issue with these advanced software tools. And that's because it is difficult to run this sort of things on Windows. And by the way, I'm not suggesting that everybody moves to Linux. That's a insane idea, which I would not recommend, just like quite a lot of these things, but something to consider. A lot of these advanced topics, yeah, as I said, difficult on Windows. These pipelines are actually running on a Linux system, which is why you can't use programs such as Inventor, because that's Windows only, and there aren't free tools to be able to interface with it. All these servers run Linux. The automation and control of these sort of things may also be easier on Linux. And also there are a lot of tools, but CAD is the last one, so there's a lot of issues, so I wouldn't really recommend it. And also Linux is kind of fractured the tools. So again, all of these things in the advanced section, these are, if you really need it, I won't suggest that all of you do it. Just like with all the things in these this presentation, which I've gone through in the last hour, these are just suggestions. These are just things which you could do on your team. And I would just pick the ones which are suitable for you and which fits best with your team philosophy. Like most teams don't need these advanced team features. A lot of teams might just be fine using file shares, or they might use basic Git and then just make sure that people don't touch the same file at the same time. Or other teams with a large software team, they might decide to develop these solutions and approaches. So finally, are there any questions?
Hi, that was really, really good. We do have a few questions for you.
Okay.
The first one came in was, do you distribute the design process bottom up or top down?
I think this year, sorry, I think it's last year, we went from a bottom-up design approach, and I don't think that was a very good. We don't think that was a very good approach, because that led to all sorts of issues where we were trying to merge things together. Because on a robot, you have a very confined space. Your robot can only have a certain frame parameter. So when everybody's doing their bottom-up design, there's only vague communication about where the keep-out zones for different components are. You can have collisions, and that was extremely difficult to deal with. So I would go for a more top-down design where you basically sketch out the parts on your robot and say, okay, the lift will be here, the intake will go here, just so that you have keep-out zones and just so that's easier to manage. But it depends. It's kind of a mixture of both, because there are advantages to bottom-up design, more autonomy. Like people can go off and have a completely different solution, but yeah, we had issues with bottom-up.
Great. The next question that came in was, do you access designs from previous seasons, or do you start completely fresh each year?
Because we haven't, our team, despite being quite an old team, we don't actually have much access to previous year's designs. For example, a lot of the old designs, they've been lost to time. It's on somebody's hard drive of a team member who's just left. And also there isn't really much that we can reuse. Like we don't do custom drive bases, and we haven't really been happy with our designs from previous years. But what we have done is that some teams, some of the major teams in America, they do publish their CAD, and we do pull that down. But in future, we are looking to be able to look at designs from past years. For example, we have our 2020 design. can we find our 2019 design? Would be run the back. Yeah, yeah, we do have a design from 2019 here, and we did have a look at it, but we weren't really happy with the way we did it in 2019, so we didn't look at it too much.
Okay. The next question that came in is, what do you do if you accidentally commit some information that's sensitive, like passwords?
Yes, that's a big thing, especially that is why I strongly suggest you using a private repository, because there are actually malicious bots on the internet which goes through and scans for passwords in repositories. For example, password to your AWS account, then it'll take that password and mine cryptocurrency. But more to your question, as I said, the first line of defense is to make it private. And once you commit it, I would try to alert the administrator of your repository, because you can basically run a command to forcibly remove a commit. Usually, most users can't do that because obviously you don't want people randomly removing commits. But also remember, when you run commit on your computer, it doesn't actually push it to the server. So if you commit it on your home machine, then it's just on your machine, it's not on the server yet. So, and there are commands which you can run, which will basically delete a commit if it's just on your computer. But I don't know what that is off the top of my head, but there are very good guides online if you look it up. Yeah, but yeah, it is something you can do. You can delete things.
Okay, the next question has to do with Linux. And what's the best Linux to use, especially for CAD work?
The thing is that the issue with that is, honestly, there isn't really any good one, because for CAD was, as I said, CAD is one of the last holdouts where all of the good programs are on Windows. On this system, I'm running Arch, and I'm trying to get our team to use Arch potentially. But yeah, and also generally, if this is running on a server, most of the time it would be running Debian. And also keep in mind that it doesn't really matter what distribution you use, because most of the tools are compatible with it. So most of the tools don't really care about what distribution you can use. Like FreeCAD, you can just download on that on any distribution from the package manager. And I would say evaluate on a case-by-case basis on what's important for you. Like if you want stuff to be rock solid stable, go with Debian. If you want the newest features, go with Arch and all the in-between. Yeah.
Awesome. Seems like you have quite a bit of CAD experience. And so there's a question is, what if someone is brand new and wants to learn how to CAD and get better at it? What recommendations would you have for them?
What I would do is don't try to teach them during the season. That's what our team tried to do, and it kind of works, but it's very stressful. And that's not talking down to anybody who is able to do it, talking down to people who wanted to learn during the season. But during the off season, what I think is a good idea is to look at past games. Like for example, if go back 5 years, like this year we're looking at the Stronghold game, and we basically just went through and gave the new designers components of a Stronghold robot, saying, look at what some other teams did, and we want you to be able to do an intake for a Stronghold robot, and just build their confidence that way. And that's about it, I would say. Just try to build confidence by designing robots. That's the only way to learn, is designing robots. Great.
Well, I don't see any more questions coming in. So I just want to say thank you so much. That was excellent. For someone to be able to come on and do that sort of presentation in an hour, you did a really, really good job. So well done. Thank you. Thank you to Normanhurst Boys High School for allowing you to come on and for sharing your knowledge with us.
Yep.
I also want to say thank you to Project Bucephalus 5985, because they are always there monitoring the chat and helping out behind the scenes. So if there's no other questions, thank you all, and we'll see you next week.
Yep. Thank you.
Bye.